Okay, let's talk a little bit in greater detail about ionic bonds. And so, last class we learned about ions and how there can be two different types of ions, either cations or anions. Well, ionic bonds are formed between ions, and so that's why it's called ionic bonds. Anyway, you're supposed to write down, so please be following along in your guided notes. You're supposed to write something here for ionic bond. And it's a bond formed when one atom transfers its electrons to another atom. When one atom transfers its electrons to another atom. So one atom will totally give its electrons to the other atom. And then there's going to be a positive charge and a negative charge, and they will attract each other, and that's what the ionic bond is. We'll go into that in greater detail here in just a second. Ionic bonds occur between a metal and a nonmetal. So we've got to have a metal, and the other one's got to be a nonmetal. So if you look at your periodic table, in order to get an ionic bond, we need something below the staircase. So metals are found below the staircase, and we need an element above the staircase. And nonmetals are found above the staircase. So if you look at it, and for example, maybe the most famous ionic bond forms between sodium and chlorine. Well, sodium's below the staircase, it's a metal, and chlorine is found above the staircase, it's a nonmetal. So it's got to be one metal and one nonmetal. Ionic compounds are compounds that contain ionic bonds. So this is a compound, it's got more than one atom, and it's held together by an ionic bond. So that's called an ionic compound. Ionic compounds contain two different elements, a metallic cation and a non-metallic anion. So this is the metal, and it will be a cation, and this is the nonmetal, so it's an anion. Okay. So let's look at that in a little more detail. I know this isn't in your guided notes, but please pay attention up here as we go through this. I'm going to ask you a lot of questions about it. So let's start here with sodium, guys. How many valence electrons does sodium have? One. It's got one valence electron. Easier for it to lose that one valence or gain 7 more? Lose. What charge is it going to have if it loses that one electron? A +1 charge. So does it really, this is its valence electron here. It really wants to lose it because that's easier for sodium to lose that one valence electron than to gain 7 more. Well, let's find out why sodium really likes chlorine on the periodic table. Okay, why are these guys such, make good partners here? Well, chlorine, how many valence does chlorine have? It's got 7 valence electrons. Easier for it to lose 7 or gain 1 more? Gain 1 more. What charge does it have if it gains 1 more? A -1 charge. Okay, so it really wants 1 electron, and sodium really wants to get rid of its electron. So that's why they make such good partners. What will happen is sodium actually gives it, totally transfers it to chlorine. Okay, and so now let's see what happened here after we go and do that. Sodium now forms a +1 charge because it lost its electron. So sodium is a +1. It's a cation. Remember, cations are positive. Well, chlorine, now that it has this electron, has 1 extra electron, so it forms a -1 charge. And it's called an anion because it's negatively charged. Okay. Well, what we essentially have here is sodium, which is positive, and chlorine, which is negative. What can we say about opposite charges, guys? They attract each other. So the sodium really likes the chlorine, and the chlorine really likes the sodium, and they come together, and they form a compound called sodium chloride. Remember, a chemical bond is a force that holds 2 or more atoms together. There's a force here of attraction between oppositely charged ions, and they're pulled together, and that's what an ionic bond is. That's really, and why is it called an ionic bond? Is this an ion, guys? Yeah, that's a cation. And this is an ion, that's an anion. They come together because opposites attract, and that's what an ionic bond is. One's a metal, one's a non-metal. So hopefully that makes sense. Okay, we're going to learn how to predict which elements like who on the periodic table. And the way we can do that is by obeying the octet rule. I know we've talked about this before, but there's something that you need to write down right now in your guided notes. So let's go through it. The octet rule states that ionic compounds form so that each atom, either by gaining or losing electrons, has an octet, which means 8 valence electrons in its highest energy level. They try to have the same electron configuration as a noble gas. Everyone wants a full set of 8 valence electrons. Except for hydrogen and helium, how many do they want? 2. Everyone else wants 8. Okay, so a couple of trends that you're going to notice. Metals will tend to lose electrons. Everything below the staircase, they like to lose electrons. And when they lose electrons, they form a positively charged cation. So the metals will form the cations. The nonmetals will tend to gain electrons. And when you gain electrons, you become negatively charged. Negatively charged ions are called anions. So the nonmetals will form the anions. So everything above the staircase are going to form the anions. Okay. So hopefully you're keeping up with the notes there. Okay. So everyone wants 8. The metals will lose, forming cations. The nonmetals will gain electrons, forming the anions. Now, I've got a few more slides here that kind of explain ionic bonding, but we've already talked about it, so I'm going to go kind of fast. Sodium has 1 valence electron. Chlorine has 7. If you look at it here, what's the highest energy level in sodium? 3. Okay? Well, it's easier for it to lose this 1 valence electron, so what you're going to see is it's going to give that valence electron to chlorine. So now if it doesn't have it, that one's gone. What's the highest energy level now? 2. How many electrons does it have in that second energy level? 8. So is it obeying the octet rule? Yeah, it is. Okay, well now chlorine, if it gets another electron, it had 5 before here, what's it going to be here now? 6. So if that becomes a 6, now 3 is the highest energy level there. How many electrons in the third energy level? 8. So are they both obeying the octet rule now? Sure. And that's what happens when they form that bond. So that's kind of what this slide is showing us. Okay, so you've got 8 electrons here and 8 electrons here if it transfers it. Okay, and then this one becomes positive. Sodium becomes positive cation, and the chlorine becomes a negative anion. Okay, and then remember, opposites attract. Since the sodium's positive, chlorine's negative, these guys are going to attract each other and form sodium chloride, a compound. Okay, let's go to this. In your guided notes, there's a spot where it talks about monoatomic ions. I want you to make a note. What does mono mean, guys? Mono means 1. Okay, so please make that note. Mono means 1. What does atomic mean? It means atom. Atomic means atom. So when I say this, monoatomic ions, here's what I mean. A monoatomic ion are 1 atom ions. So they're only 1 atom, but they form a charge, so they're an ion. Examples. Where it asks for examples, I would like you to write this down. Hydrogen, sorry. I was looking at Na and I wrote H. Hydrogen forms a +1 charge. So write this on the examples. So hydrogen's +1, as we see here. All of group 2 elements, like beryllium, form +2 monoatomic ions. Okay. All of group 15, like the nitrogen, will form a -3 charge. Oxygen forms a -2, and fluorine forms a -1. So these are examples of monoatomic, because it just has one atom, ions, monoatomic ions. All right. Now let's talk about something else. It's called an oxidation number. Oxidation number is the charge of the monoatomic ion. So when you hear somebody ask you, what's the oxidation number? Well, you just say what the charge is. For example, what's the oxidation number of sodium? Well, its charge here is +1, so it would be +1. What's the oxidation number of oxygen if it has a -2 charge? Well, it'd be a -2. Okay. Chlorine, if its charge is a -1, its oxidation number would be a -1. So anyway, that's what an oxidation number means. Okay, now let's talk about something that's very important. There's a spot in your guided notes where it says polyatomic ions. I want you to underline poly. What does poly mean, guys? It means many. Yeah, more than one or many. And what does atomic mean? So these, when I say polyatomic ion, you think many atom ions. So here's the definition. They are ions made up of more than one atom. So if the ion is more than one atom, we say it's polyatomic. Okay, and there's a spot in your notes for examples. I want you to jot this one down as an example. So parentheses, NH4 has a little subscript here, and then it has a +1 charge, so a little plus sign up here. Okay, and then another example would be this one down here. Parentheses, PO4 as a subscript, and then a -3 as your charge. Those are just two examples of polyatomic ions. Okay, and then what this bullet is saying right here is that polyatomic ions always occur as a single unit. You can't break this unit up. But if I had more than one ammonium ion here, I would use parentheses. And say I had two of them, I'd have to put the 2 on the outside of the parentheses. So whenever you change the number of polyatomic ions, you've got to use parentheses and then put the number on the outside. We'll go through that later on, but that's just kind of an introduction. So notice how there's more than one atom here. What is N? Nitrogen. What's H? Hydrogen. So that's a polyatomic, and it's an ion because it has a +1 charge. This would be a polyatomic cation. This one down here, phosphorus and oxygen, so it's polyatomic, more than one atom, has a charge of a -3, so this would be a polyatomic anion. All right, I handed you out a table that looks like this. I want you to get that table out now, and I want you to put a star by a number of these that I would like you to memorize. These are the ones that you're going to see most often. Now, they're all common. All of these are common. But these are the ones that first-year chemistry students should know. Okay? So I'm going to put a star by this one. Okay? You should know ammonium is NH4 with a +1 charge. You should also know nitrite. You should also know the next one below it, nitrate. And then finally in this column, you should know hydroxide is OH minus. OH with a -1 charge. Okay? Those are very common. And then in this other column over here, I would like you to know these ones. Okay, sulfite. Sulfite is SO3 with a -2 charge. Sulfate is an SO4 with a -2 charge. And then finally, this one down here, phosphate. Phosphate is PO4 with a -3 charge. Have you guys heard of these terms before? I bet you've heard of phosphate before, right? It's in fertilizer. Sulfate, sulfite, hydroxide. This one's very important, okay? You just got to know that hydroxide is OH minus. Nitrate, nitrite, and ammonium. Okay. Before we move on, what do you notice about all of the charges here? Are they mostly cations or are they mostly anions? Almost all of them are anions, which means they have a negative charge. What's the only one with the positive charge? Ammonium is the only one with the positive charge. So this is the only common polyatomic cation. Just something to kind of pay attention to there. Also, another thing that you might notice, NO2 and NO3 are very similar. Look at how their name ends in ite and ate. Okay. SO3 and SO4 are very similar. Look at how their names end. Sulfite and sulfate. So a lot of times you'll see the ending just change a little bit. Okay. We almost got this part. There are these polyatomic ions that are known as oxyanions. Oxy means oxygen. So let's make this note in your notes. Oxy means oxygen. An anion, well, we know what an anion. This is a negatively charged ion. So an oxyanion is a negatively charged ion that has oxygen in it. And you'll see a lot of the polyatomic ions on that chart have oxygen in it. And so let's talk about this for a second. I think you're supposed to write down what an oxyanion is. Okay, so take a second. It is a polyatomic ion composed of an element, usually a nonmetal, bonded to one or more oxygen atoms. Bonded to one or more oxygen atoms. There's a rule for naming oxyanions. Look down here. NO3 and NO2. Which one has more oxygens? Well, the NO3 does. It means this 3 right here means there's 3 oxygens here. If there's bounded to more oxygens, it ends in 8. So I don't know, we just got to come up with some way to remember that. When I was learning it, I always thought that I like to eat a lot. So whatever one has more oxygens here ends in 8, because that's kind of like eat. Or you kind of see that? Okay, if it's got less oxygen, so this one only has 2, it's going to end in ite. So there's nitrate because there's 3. There's nitrite because there's less oxygens, only 2. Same rule applies. Which one has more oxygens? Well, this one has 4 oxygens, so it ends in sulfate. This one has 3 oxygens, so it ends in sulfite. Okay? So you'll notice that on that table. Yeah, I'm going to let you use this polyatomic ion table on the test. You'll always have it available, but I think it's worthwhile just kind of learning how they're named and some of the common ones. Okay, let's end this video with this practice problem. Okay? I want you to go through and name, let's see, there's 7 of them here. Just use your polyatomic ion table and name them. So let me do the first couple with you. Which one is OH minus 1? Hydroxide. So just write the name. Now I think in your book number 2 is across. So which one is NO2?
Nitrate.
Is it nitrate or nitrite?
Nitrite.
Yeah, it ends in ITE, so this is nitrite. Nitrite. Okay, take a second now. If you're watching the video, hit pause. Go through and fill out the rest of the names of these And when you're finished, hit play. We'll see if you got them right. Okay, guys, let's see if you got them right. Please help me out. What is NO3 minus? Is it nitrite or nitrate? So it ends in ATE. Remember, if it's got more oxygens, it ends in ate. If it's got less, it ends in ite. Okay, SO3 and then SO4. So they're going to be named similar. What is SO3 called? Good. Sulfite. It's got less, so it ends in ITE. This one has more oxygen, so it ends in ATE, so it's called sulfate. Okay. Number 6, what did you guys put for this one? Phosphate. Okay. And then finally, number 7, what is that one called? Ammonium. Ammonium. And yeah, remember that ammonium is the only one that's the only common polyatomic ion that has a positive charge. That's the only cation on that table. So anyway, please keep this table with you, the common polyatomic ion table with you at all times. We're going to be using it in the coming class periods. But so hopefully you understand what a monoatomic ion is, and you've become familiar with some of the more common polyatomic ions. Okay, and hopefully this video helps.